Oh, hey, Corey. You're muted, by the way.
Must be something on Microsoft's side because I couldn't get in worth a hell. I mean, holy cripes.
Hey, Hunter, how's it going?
It's going. It's going okay.
All right. It's working a little bit here. All right. Kind of different to do Zoom, but we'll see if we can make it happen.
Hi, this is Matthew. I'm sorry, my mom's Zoom account is linked to my computer.
That's okay. I'll make a note of that.
Yeah, I'm having problems with Team too.
Yep. All right, we'll see if we can get any more participation here.
I'm in like a general meeting with 2 other people, and I put it in the chat that we're in Zoom, but I mean, they're still in the general meeting, so
Oh,
I
okay.
don't know.
All right, well, we'll see how it goes. Because I can't even get Teams to open up, so.
I can get it to open up, but I can't join a meeting whatsoever.
Yeah, I had a weird little guy with a construction hat on saying, we're sorry, we've run into an issue.
Yeah, I got
And
that.
then and then we're sorry. Okay. They are very sorry, but it's not happening. All right. I mean, I sent an email. That's how it's supposed to work, and we are recording it, so we'll just do what we're able to do here with who we have available to us to be here. So I am on my agenda. And when I go there, I see I'm supposed to check my list of people. So I'll do that first. Here's my list. And here are the people. So interesting that Zoom has its own way of organizing people, not by alphabetical order, but anyway. Okay, so Matthew, you're able to change your name, that's fine. All right. So we've started recording already, which is fine. And then we need to look at the schedule. So I'm going to try to share my screen here. And there we go. And as it turns out, I think that there's a lot of software sharing that goes on between Teams and Zoom. But anyway, here we are. Here's the schedule. And what we've got today then is the Ides of March, the 15th. And we do not have homework scheduled for today, but we do for Wednesday, homework set number 12. Then we have quiz number 8, which is due on Thursday. These are substantial assignments. They will take a significant amount of your time. So just as a heads up, the more you are able to do, the better, and the sooner and the faster. Certainly, again, as always, if you need an extension, let me know and I can give you an extension. But this is, how should we say this? This is the ramping up, okay, of the course. We will be doing a lot more in a lot less time, okay, because we were kind of coasting there for a bit. We're not anymore. We're going full speed ahead. So that is the sharing of the schedule. And then the next thing is whether you have any questions. All right. So does anybody have any current questions about anything? Morgan, I see you there, so I'm going to put you on my list as attending.
I know you mentioned it'll be a longer homework set. How long do you think it on average would take about?
Well, this is difficult because according to the software, it only takes half an hour. So if you know what you're doing, then it won't take very long. It's just a matter of whether you are able to get to the point where you actually know what you're doing. And so that's generally what takes a while, is watching the videos. I have, let's see, how many videos do I have out there? There we go. I have 1, 2, 3, 4, 5, 6 videos, all of which are about 10 minutes long, or somewhere in that neighborhood, maybe less. So then they've got an hour of video watching. Well, when you do that, you also have to actually write down stuff and keep track of stuff by taking notes. So it might take you longer than an hour to watch all the videos. So then the actual doing of the homework might not take you very long, but getting to the point where you understand it so that you can do the homework is probably going to take you, I don't know, a couple hours. So does that answer your question, Kaylee?
Yep. I just wanted to,
Okay.
see if it would be a really long homework. I mean, it's 19 questions, I think, compared to previous homework sets. So yeah, thank you. Yep.
And there are substantial questions on the homework which are multiple choice, and there are substantial questions on the homework where each question has like 10 parts. So yeah, it's in the sense of how much material there is to go over there. But once again, what I said, if you are comfortable and understand the work, the homework itself will not take you very long. Getting ready for the homework will take a substantial amount of time. All right. Any other questions about anything currently? All right. So we will go ahead and get started then into our activity to be able to work on the information that we have here. And it's, shall we say, work in progress. And you'll see that once I get out sharing the common document. So make that happen here. Anyone with the link. And we'll just make it an editable document just for the sake of doing something like this. And we'll go out here to, once again, I will send this out by email since not everyone will be available. Document for today's class, March the 15th. And submit that. All right, so the link to the document is coming in your email. And you should be able to see that. And as soon as I see, there we go, we got people popping up here. A quagga. No idea what a quagga is. Interesting. Yeah, Google is, if nothing else, creative in terms of what animals they pick. It's not like rabbit, bear, lion, tiger, stuff like that. That's okay. They can do what they want. All right, so we're talking about hypothesis testing. And this is basically the idea of how decisions have been made in statistics for the past 100 years. People have been using the process of hypothesis testing. Now, of course, I would recommend that you watch all the videos. You may not have previous to this class. If you did, that's fine. But it's really important for you to get a good handle on what hypothesis testing is. And the basic idea is, if we say, what is hypothesis testing? Then it is proving a difference between a population measure and a standard number. At least that's where we're starting, okay? We're going to adjust this definition as we go. But for right now, what we're thinking about is where we have a difference between some kind of a population measurement and some kind of a standard number that's been given to us, okay? So what I'm going to do is I'm going to run through an example of how that works so that you'll be able to understand more of the process. And then we'll see how far we can get with that and hopefully answer your questions along the way. Okay, so I'm going to go to a link here and I'm going to put this link into the document. So this is from one of my favorite websites, 538.com. And what it's talking about is the approval rating for our President Joe Biden. And the question is whether specific polls are using the same methods, okay, then we would expect that the group of people which are used by the polls will give us the same results or similar results, right? And we want to know if there are any polls which are done in such a way that they're not getting the same results as what we would expect, okay? So the question that we're going to deal with, the question is the population which is used by, and I'm going to find which one I'm talking about here, which is used by Rasmussen on March the 8th, the same as expected. Okay. So what happened on March the 8th? On March the 8th, Rasmussen had a poll where they had 1,500 people that they surveyed, and they came up with 50% approved of Joe Biden, his conduct as a president or whatever you want to call it. Okay. But the expected number that we had here was 53.4%. Okay. So then the question that we have is, is the population used by Rasmussen, or I should say, does the population used by Rasmussen have a lower opinion of Joe Biden than expected? Now, this is an important part of the process, okay? When I look at this thing and it says 50%, and the expected number, according to the software or the techniques from this site, 538.com, they were saying, well, it should be 53.4% if we base it on what other polling organizations are doing. When I look at that, I say 50% is lower than 53.4%. And so I'm going to choose to say, I want to do something about the fact that it's lower. However, in your textbook and in other textbooks, they say we should not choose a direction here. We should assume that we don't know, that it could be either lower or higher. But I'm going to do this according to my expectation that this is a lower poll. So I want to say, is it significantly lower, or does it show that the population number is lower? Notice that the 50% from the 1,500 people, that's a sample number. I want to know if their technique, what Rasmussen is using, if their population is different. Samples change, but I want to know if their method is actually giving us a lower result. Okay. I know the sample is lower, but what I want to know is, was that just a random event, or does that actually reflect some substantial difference or a significant difference in their method? Okay. So in order to do that, then if you can go to Blackboard and click where it says on week number 10, the steps for hypothesis testing. It's very important that you understand how these steps work, okay? So if you pull that up, I want you to have this document open from now until the end of the term. Okay, so that you can understand the steps for hypothesis testing. Now, the first thing that happens is that we would check the requirements, sample size and normality and all those things. We're going to skip that part, but certainly the textbook goes through and says, well, n times p times 1 minus p is greater than 10, which we've already talked about a couple of times. And we're just going to say, yeah, 1500 is a high enough sample. I think we're fine. Then we say determine the hypotheses, what are called the null and the alternative hypotheses. And based on what I've already done, I'm going to have the null hypothesis is reflecting the standard number that I was working with. Hypothesis, there we go. And it is used, it's the letter H and then a subscript 0. Okay. And in typesetting, we just use an underline as a shortcut for that. H sub 0. And this would be the statement that the population proportion is equal to 0.534. The null hypothesis is a standard statement about our population, which we assume to be true. We are assuming that the Rasmussen population is the same. And then we say, can I prove a difference? So then I say alternative hypothesis. I'm having trouble spelling. And this is H sub 1. And that would be that the proportion, the population proportion from Rasmussen is less than 0.534. So these are the statements of the problem. My hypothesis, I start with an assumption. I say, let's just assume, it's a hypothesis. Let's assume that the Rasmussen group was 0.534. If I assume that, then how likely is it that I would be getting a 0.50? So it's assuming something which I'm hoping to prove is false. I'm assuming that it's 534, but I assume that in order to prove that my sample of 0.50 would be an unusual result in that situation. So then I would be proving that something is wrong about my assumption. All right, so does anybody have any question about anything right now based on what I've already said? All right, so what I'm going to do is continue in the process. I've determined the hypotheses. And when I say that I have this hypothesis that it's less than 0.534, then this is, hoping I'm right, this is a left-tailed test. Okay, so I'm hoping that my sample number is an unusual event inside the left tail. Because it's less than, then I'm looking at the probability of it happening. So I'm considering a distribution of things. And then if it's an unusual event, it's going to be in the tail. So it's a left-tailed test. So then, there are 3 approaches which are listed here in the document, steps for hypothesis testing. The first one is a classical approach. The classical approach says compute the test statistic or the test value. Now, in the textbook and also in what's called the formulas and tables section, which I posted on Blackboard, it will give you a formula for the test statistic. I'm not requiring that you know how to do that to find the test statistic. What I want is that you are able to use StatCrunch in order to figure out what this test statistic actually is. And so then when I say the test value or the test statistic, it is a number to find an unusual value using Z or T or chi-squared. If it's a proportion, we use Z. If it's a mean, we use T. And if it's a standard deviation, we use chi-squared. Since we're talking about proportions here, we're just going to use Z. So then I'm going to go out and share my screen here so that we can get to StatCrunch. StatCrunch, there you are. Okay. And I want to not show you that right away. Some of this process is familiar, I hope, because we've done it in the past. And that is, I'm going to go to Stat, Proportion Stats, One Sample with Summary. If I were doing something with the mean, I would go to T-Stats. If I'm doing the standard deviation, I would use variance stats. But right now I'm doing proportion. So then, I need my number of observations, which was 1,500. And I need my number of successes. Well, number of successes, that was the 50%. So this would be just 750 out of the 1,500. Now I'm going to put in the information for my hypothesis test. So I'm comparing it to the expected number, which was 0.534, and I'm doing less than. So then I'm just going to hit compute, and it's giving me a bunch of numbers. It shows, as you can see here, H sub 0 or H sub A. Some statistics books use H sub 1 for the alternative. Some use H sub A. Doesn't matter. The null hypothesis, it's equal to 0.534. The alternative hypothesis, it's less than 0.534. So then when we look through this, we see a bunch of stuff down here. The test value is the Z statistic here. So the test value is negative 6.4 or negative 2.64. That's better. So I'm going to put that in my document. Z is equal to negative 2.64. So then, if I think about this, if I have a Z-score of negative 2.64, that's pretty far out there to the left. So this seems to be possibly an unusual value. Now, in the classical method, the next thing that we're going to do is we're going to find the critical value and the rejection region. And I need something called alpha in order to find the tail. Okay, so when I say up here, does the population used by Rasmussen have a lower opinion? Somebody's got to tell me what alpha I'm going to use. Whenever I do a hypothesis test, I have to be told. So I'm going to say use alpha equal to 0.05. That's a common one, but it could be 0.10 or 0.01, but we're going to use an alpha of 0.05. So we say, what is the critical value? And we talked about this a little bit before. It is locating the position of the tail. And again, so what we're looking at here is a left tail test. and we're using z-scores. So I want to find the z-score, which has a left-tailed area of 5%. Okay, so I'm going to see if somebody can find that for me. All right, if we go to StatCrunch and I want to find the z-score for the lower 5%, the bottom 5% of a data set. So can anyone tell me what that number is? Oh, I see Russ has also joined us. I'll put you on my list. Okay, Anthony, I see your name on my list. Oop, but Anthony's gone. That was fast. These things happen. All right, so I'm looking for the z-score for the bottom 5%. Can someone tell me what that number is? I see Anthony listed here, so I'm going to mark Anthony as being present. Okay. Matthew, can you tell me where I need to go to look at z-scores in StatCrunch?
I'm sorry, pass.
All right. Hunter, can you tell me where I need to go to find z-scores in StatCrunch?
If I vaguely remember correctly, it's, I want to say go to stats, calculators, go to normal.
That's right.
And then I just trying to guess I'm just, yeah, just then it's mean. You got to fill out your mean and standard deviation. I haven't gotten that far yet. I was still trying to bebopping around looking for the right thing.
Okay. So do you see my StatCrunch window that has the normal calculator on it?
Yeah, I've gotten that.
Okay.
I've said exactly where you're at.
Okay. So when we say z-score, then the mean is 0, the standard deviation is 1.
Yeah.
So right now we're set as z-scores. That's the normal calculator we're looking at right now.
And you're looking for the bottom 5%, you said.
I am.
You're looking for 0.005 or 0.05.
0.05, yes. And it's already set up to go to the left.
Mm.
So I can just put 0.05 and compute. And here's my number, negative 1.645.
Yeah, got that.
All right. So now my critical value of z is equal to negative 1.645. And I'm putting that in the document. So then the next thing that's in my list is to say, what is the rejection region? And the rejection region is actually the interval for the tail. And so then I'm going to type in the document, the rejection region then would be z is less than negative 1.645. It's a left tail test. So I'm going to the left of that critical value. All right, so does anybody have any question about critical value and finding that number or test value? Okay, so we have a number from the sample, which was negative 2.64. That's telling us how unusual the sample is. That's the test value. We have another number, which is just from the mathematics, which says an unusual value would be anything below negative 1.645. this is given the fact that alpha, or the region out there, is an area of 5%. So now I have my critical value, and I have my rejection region, and I also have my test value. Then if I look in my document of steps for hypothesis testing, it says make a decision. If the test statistic is in the rejection region, we reject the null hypothesis. So if you look carefully at the graph here and you say, where is negative 2.64? That test value is in the rejection region. So we have a situation, so we are going to reject the null hypothesis. So this is our decision. Our decision is to reject the null hypothesis. I'm typing this in the document here and spelling it wrong again. Reject the null hypothesis, or reject H sub 0. Now, it's really important that you get a handle on what that actually means, okay? Then we say, what's the meaning of that? If I reject the null hypothesis, I reject the concept that it would be equal to my expected value. And so therefore, I prove the alternative hypothesis, okay? So what I'm going to type here is, there is evidence to prove the alternative hypothesis. This is our goal, okay? When we see that I have a polling organization which gives me a 50%, but it's lower than what I expected it to be, it would seem reasonable that I'm going to try to prove that there's something different about this, that there's something different about this particular poll, that it doesn't match up with what I expected it to be. And that is what I have done. I have proven this. There is evidence to prove the alternative hypothesis. Now, what does that mean then, or the interpretation? The interpretation of that is that the population proportion, or the population which is used by Rasmussen, does have a lower opinion of Joe Biden than expected. So I'm just going to put that in here. Yes. The population used by Rasmussen has a lower opinion of Joe Biden than expected. So something's going on here, all right? When I dealt with these 1,500 people, and the group that they used came out with a 50% instead of a 53.4. It's like, I did not expect that. That's substantially lower, in the sense of it did not happen by chance. This was not just a random thing. Okay, so this is going through hypothesis testing by using the classical approach. And this is our goal, is to make this happen. All right. Any question about this currently? All right. So we're going to do another example. And what we're going to have here is, pardon me, we're going to have a situation on March the 11th. We had a similar poll, and it was 52% out of 1,500. And at that point, on March the 11th, we had a value of 53 was our expected. And our expected was 53%. So we're going to go through the same process now. We've just changed the numbers a bit, and we're going to see what happens when we do that. Okay, so I go through the same kind of a process. My null and alternative hypotheses are the same. Well, except I'm going to change this to be just a 53% instead of 53.4%. Okay, so what I want to have happen here, I'm going to stop my sharing. I would like for you guys to go out there and see what you get for a test value when you use these different hypotheses. And when you have this different sample number. It's 52% out of 1,500 now. All right, so let's see. How many people agree with the Z statistic of negative 0.78? You can type in I agree right next to it there. Okay, we have an agreement. 0.78. Okay, and yes, that is correct. So if I change my numbers, I change my sample number, it's 52% of 1,500. I change my alternative and null hypotheses to be 53 instead of 53.4. Now I have negative 0.78. So then my critical value and rejection region are still the same, because my alpha has not changed. Okay, so then I'm going to put that in here. The rejection region is Z less than negative 1.645. So then what happens? Well, we say do not reject the null hypothesis. But many people don't quite get what that actually means. When we say do not reject the null hypothesis, and we say what is the meaning of that, we do not then accept it, okay? We do not go back and say, oh, well, then it is equal to 0.53, because it's not equal to 0.53. It's actually 52%. It's not 53%. So we say it is not equal. I've not proven that they are equal. But what I'm going to say is there is not enough evidence to prove the alternative hypothesis, H sub 1 or H sub A, depending on how you want to put it. And so what we say here is no decision. This could be a random difference. We know that when we take samples, sample numbers always change. If you go out and take another group of 1,500 people, you'll get a different number. And since the samples could change a little bit here and there, the difference between 52 and 53% is not enough to prove anything. Yes, 52% is lower, but it's not enough lower to prove that there is an actual difference happening here. So then we would say, in the interpretation of this, no decision. We cannot say anything about this. We cannot say that it's the same, nor can we say that it is different. It's just something. It's just, it could have been a random thing. It might not be a random thing. But it just is what it is. We can't make any decisions about it. So when we look at something like this, we have to consider the possibility that anything that we're getting could be just based on random chance. But by using this process, we have determined that previously it was substantially less, what we call statistically significant, in terms of the difference between the 50 and the 53.4. But now here we say, oh, I can't tell. I don't know if it's different or if it's not. There's not enough evidence to prove the alternative. All right, so does anybody have any question about this so far?
I'm wondering how you got the test value. Like, where did you go on StatCrunch for that?
Okay, so I'll show you. So I'm sharing my StatCrunch here, and I'm going to just move this out of the way a little bit. So I'm going stat, proportion stats, one sample with summary. And I need to put in the proper number of successes. We'll redo the first one because I want to be able to compare the two here. So this was 750 out of 1,500. And then my values were 0.34, and this is less than. All right, are you following my process right now?
Yep.
Okay, so when I hit compute, then what I'm looking at is the Z statistic. That is my test value. And again, it's a measurement of how far my sample number is from what I had expected it to be. And in the first example, that Z-score was negative 2.64. And in the second time, it was negative 0.78. Does that work for you?
Yep, thank you. I was looking at the wrong number on the chart.
Okay. All right. Now, in our steps for hypothesis testing, there is a second way to do this problem. And this is called the p-value method. The p-value method, we start the same way. We compute the test statistic, but then we get something called the p-value. And there's a lot of confusion about what the p-value actually represents. The p-value is the probability of having an extreme sample like the one we obtained. So I assumed at the beginning that in the first situation that the population was 53.4%. What are the chances that it would be 50% or lower? Okay, so the p-value, and StatCrunch is nice. It'll find it for me. The p-value is 0.0041. So for my first example, the p-value is equal to 0.0041. Now, many times we use a capital P in this situation, but unfortunately not always. So when we say, what is the p-value? It is a very small number. So what this is telling me is that it's a very small chance that this was just a random event. This is a very unusual thing to happen by chance. So we say, if it's an unusual thing to happen by chance, then maybe it's actually an indication that something is actually different. The example that I would use would be like, if you go to some kind of a book club and people have told you, yeah, most people, it averages about 40 years old in this book club. And you walk in the door and everybody is 70 years or older. Then you say, there's something going on here. This is not what I expected. This is unusual. It was supposed to be 40 years age, but everybody is 70 years of age. There's something going on. And that's the same thing here. We expected it to be 53.4%, but it wasn't. It was 50%. We say this is an unusual event because it's not likely for this to happen just by chance. So then we have a low p-value here, and our decision then, the decision rule is that this p-value is less than alpha. And if the p-value is less than alpha, then again, we are going to reject the null hypothesis. And then we would make the same conclusion as we had before. P-value is basically what everybody's been doing for the past 100 years in statistics, or 50 years, or something like that. Most research studies reflect the idea of the p-value, where they say this has a low p-value, so it's not by chance. This is an actual trend. There's something going on here which is causing this to be an unusual event. So that's the big deal in statistical research over the past 50 years or more. Low p-values. Now the facts are, okay, when you get a low p-value, it all depends on what kind of assumptions you made and how you got your data and everything else. So low p-values just by themselves don't necessarily tell you what's going on. Sample sizes are also important. And all of those things interact in order to give you a low p-value. That doesn't tell you it is or isn't a thing. You have to look at things more carefully. You can't just go by that number and say, oh, well, that tells me everything's fine. That's not how that works. Now, if we go to our second example, it's also showing the p-value, and that p-value is 0.219. Well, if that's my p-value, then it certainly could have been just a random event. There's a 20% chance, if you want to say, or 22% chance, that this difference between 52 and 53%, that could just happen by chance. And so we say, oh, well, okay. Even though it might be a lower probability, it's not enough. There's not enough of a difference here to say that I've proven anything. So then we would say the p-value is greater than alpha. So we do not reject the null hypothesis. So we've run out of time here, but hopefully you can see that everything that we've been doing right here, we have a structure. We could do the exact same things with finding the mean using t-scores and finding standard deviation using chi-squared. It's the same process. We have a null hypothesis, an alternative hypothesis. We work through the numbers, we compare the numbers, we make a decision, and then we draw a conclusion. And then we figure out what it actually means. But we're always looking for something, whether it's proportion mean or standard deviation, to be different from some kind of a standard number that was given to us in the situation. All right. So are there any final questions here? All right. So what I'm going to do then is I will post this video, hopefully on Blackboard or something. I'll get this video out here so that you can all take a look at it and work through these problems. Next time then we'll be working with the confidence interval as a method. But again, I definitely recommend that you spend substantial amounts of time on this. It's going to take you a while to get the mechanics of this down and then to be able to do the homework and the quiz. All right, so if you want to unmute yourselves and say goodbye to your classmates, I will plan to see you all on Wednesday.
Bye.
See you later.
Bye, everybody.